geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. The escape velocity from the Earth's surface is v. Let me write that point. Escape velocity of the object. Escape velocity. Escape velocity of object from Earth's surface. It is given v. Given v. The escape velocity from the surface of another planet having a radius 4 times that of the Earth and the same mass density. Let rho equal to mass density on Earth surface. On Earth surface. It is given that mass density at the planet surface equal to mass density at the Earth surface. And the radius of the planet equal to 4 times the radius of the Earth. Here capital R equal to radius of Earth. Okay. Then what is the escape velocity from the planet surface? Escape velocity from the surface of planet. That may be uh, v escape from the planet surface is coming. For that, as you know, the escape velocity v equal to root under 2 gr. But what is the g in terms of radius of the earth? Gm by capital R. Gm by capital R square. Gm by capital R square. So v equal to root over 2 g equal to gm by r square into r. It is equal to root over 2 gm by r. But as you know, mass equal to mass density multiplied by volume. Density into volume equal to 4 by third into pi r cube. Let us write that value. It is equal to 2 into g by r. M equal to density rho into 4 by third pi r cube. One r is cancelled. One r is cancelled. V equal to root over 2g rho into 4 by 3 pi r square. You know, density is constant, g is constant. From this, I can say that escape velocity is directly proportional to root under r square, or escape velocity is proportional to r. That means escape velocity on the planet divided by radius of the planet equal to escape velocity from the earth surface divided by radius of the earth equal to escape velocity from the planet divided by radius of the planet. Because here, otherwise I can write one more step. Here from this I can write that escape velocity divided by r remains constant or directly proportional to 1, or escape velocity divided by radius is remaining constant. That means escape velocity from the surface of the earth divided by radius of the earth equal to escape velocity from the planet divided by radius of the planet. V by r equal to escape velocity from the planet divided by radius of the planet is given 4 times the radius of the earth. 4 times the radius of the earth. This r part will be cancelled. From this, escape velocity from the planet surface equal to 4 times the escape velocity from the earth surface, 4 times the v. Look at the option. Option D. Option D is Absolutely correct. Understood clearly? Yes, this is the most expected problem as a repeating problem. That's why I am rating as five-star problem. Five-star problem means this kind of problem can be repeated. Okay. Similarly, let's take the another important problem asking like this. What is the depth at which the value of acceleration due to gravity becomes 1 by n times the value at the surface of the earth? That means at what depth the acceleration due to gravity g dash is 1 by n times the g, right? That is the question. As you know, the acceleration due to gravity at depth d equal to, right, g into 1 minus d by r. This is acceleration due to gravity, acceleration due to gravity at a depth, at a depth d. Okay, na? At a depth d. Then in the place of g dash, let me write that value g into 1 minus d by r equal to 1 by n into g. This g part will be cancelled. 1 minus d by r equal to 1 by n. From this d by r equal to 1 minus 1 by n. D by r equal to n minus 1 by n. N minus 1 by n. Then depth d equals r into n minus 1 by n. So that is the at that depth g dash will be equal to g by 1 g by n or 1 by n times the g, where g dash is the acceleration due to gravity at depth d. Okay. So look at the options. Look at the option B or n minus 1 by n. Option B can be selected. Understood? Yes, easy problem. Similarly, let us take the another important problem asking like this. A body weighs 72 newtons on the surface of the earth. Weight of the body on the surface equal to mass into acceleration due to gravity on the surface. What is the gravitational force on it at a height equal to half of the radius of the earth? You know, the acceleration due to gravity, acceleration due to gravity at a height h equal to let that is g dash, let that is g dash equal to g by 1 plus h by r whole square. Okay. Now the weight at a height h, weight at a height h equal to mass times the g dash, right? G dash, it is equal to mass times the g divided by 1 plus h by r whole square. But weight at the surface of the earth is given 72, that is equal to mg newtons. That is equal to 72 divided by 1 plus. It is given that height equal to half the radius. Height h equal to half the radius. Right? Half the radius. That is uh, half the radius. We should be very careful. It should be half the radius. H equal to r by 2. H equal to r by 2. Here it is r by 2 r whole square. Simplified. Simplified. It is equal to 72 divided by r cancelled. 1 plus 1 plus 1 by 4. 1 plus 1 by 4. Correct now? 1 plus 1 by 4. Then it is equal to 72 divided by, it is 5 by 4. 5 by 4. So, take a minute. Height equal to half the, height equal to half of the radius. Correct one? 1 by 2 whole square. Take minute. Take minute. We should not do like this. Here it is, no? 1 plus 1 by 2 whole square. 1 plus 1 by 2 whole square. It is equal to 72 by 3 by 2 whole square. Let us take another slide. Weight at a height h, double h equal to 72 divided by 3 by 2 whole square. Right? Now it is equal to 72 into 4 by 9. 9, 8 times. 8 into 4. 8 into 4. That is equal to 32 newtons. That is the answer. 32 newtons. Look at the option A. Option A is absolutely correct. Understood clearly? Yes.
Geobyte.